the thunder of powerful engines echoing in the desert air. A plume of steam billowing towards the sky. Sparks flying from electrical wires. The blast from a controlled explosion. These sights and sounds belong to one of the world's finest state-of-the-art facilities for propulsion and materials testing. In the desert northeast of Las Cruces, New Mexico, NASA's White Sands Test Facility stands ready to challenge the safety and reliability of items slated for spaceflight. The goal at White Sands is to minimize flight risks. Safety, no matter what, is the first concern. From rocket engines to film for a camera, everything flown on a manned spacecraft has to be tested. Carefully controlled test parameters determine the strengths and weaknesses in hardware concepts and designs. This testing is crucial to mission success. Taking the risk here on Earth first will help avoid having to solve a problem miles away from home in the unforgiving space environment. As part of NASA's Johnson Space Center, the White Sands Test Facility is primarily a support organization. The testing requirements for the Johnson Space Center are the first priority for this facility. However, it also supports other NASA centers, various government agencies, and aerospace-related commercial industries on a reimbursable basis. The client provides the test article and defines the technical and schedule requirements.
And that is not part of the TRR.
White Sands personnel develop and conduct the test program to satisfy those requirements. NASA's White Sands Test Facility employs a team of over 700 civil servants and contractors. This self-sufficient facility includes an administrative area, 2 propulsion test areas, and a laboratories area. The moderate weather, arid climate, and remote location make this an ideal site for propulsion and hazardous material testing. Built in 1964, facilities here can test the entire propulsion system at one time to see how the components interact. While the larger Saturn V engines, which pushed the Apollo spacecraft off the launch pad, were tested at another NASA facility, the White Sands facility began its propulsion work with the development and certification testing of Apollo's service module and lunar module engines. These engines were crucial to the success of the Apollo missions. The service module engine put the astronauts into lunar orbit. Then the lunar module descent engine landed them on the moon. The lunar module ascent engine blasted them off the moon and back into lunar orbit. And the service module engine brought them back home. 4 dozen tiny reaction control engines on the lunar module and command service module steered the vehicles through space. Over the years, White Sands has tested more than 300 engines in over 2.1 million firings. Each test is conducted to make sure that the engines are safe and reliable. In the early 1970s, White Sands began tests for the shuttle's on-orbit propulsion systems, including the orbital maneuvering system and the reaction control system. 3 high-fidelity flight-like test articles were used for the development and qualification of these systems. Recently, these test articles entered a new phase of testing. In order to identify the life cycle limitations of the shuttle propulsion systems, NASA has developed the Fleet Leader Test Program. As part of this program, White Sands will periodically operate the test articles to see how repeated firings affect the system. These test articles will undergo more firings and checkouts than any of the corresponding flight systems. As a result, shuttle component problems resulting from long-term exposure to corrosive rocket propellants and multi-mission operation can be resolved before problems occur on flight vehicles. Propulsion testing is conducted in two separate locations, designated the 300 and 400 test areas. In the 300 test area, two test stands operate at normal or ambient atmospheric pressure. These stands are hinged to accommodate rocket systems which must be tested in both horizontal and vertical orientations, such as the steering thrusters which control the shuttle's position in orbit. A third test chamber allows rocket engine tests to be conducted under simulated space vacuum conditions. The largest of these, Test Stand 302, was extended to a height of 58 feet during the Viking Mars lander program in the early 1970s. At that time, it was used to simulate the physical and biological effects of a rocket engine landing on Martian soil. This work led to improvements to the rocket engine and its fuel prior to the launch of the Viking probe. The stand has since been modified to accommodate vacuum testing of space station propulsion systems. One of the largest instant steam generating systems in the country is located in the 400 test area. It can generate over